Mobile devices are now powerful enough to run local AI models between 1 and 4 billion parameters directly on the device. If you are building an application, you have to choose the exact right model for your specific hardware constraints. You might be weighing a 3.8 billion parameter model like 5.4 Mini against a slightly smaller one like Qwen 2.53b. To make that choice, developers almost universally pull up a centralized AI leaderboard. They look at the top-ranked models and read those rankings as definitive proof of quality. But building a mobile app based on those massive aggregated lists introduces a major blind spot into your engineering process. The data on those public boards is often months old, and it is calculated on massive arrays of enterprise GPUs. That hardware environment looks absolutely nothing like the thermal-constrained smartphone where your app will actually operate. Then there is the scoring metric itself. Leaderboards rank models using a single flat percentage. If Model A scores 56% and Model B scores 54%, Model A sits higher on the list. This chart shows two models separated by a 2% gap in accuracy. But expanding the view to include statistical confidence intervals tells a different story. Those error bars overlap heavily. That 2% gap isn't a measurable advantage, it's pure mathematical noise. Millions of dollars in engineering time are spent ripping out and replacing models based on these statistical illusions. The mobile LLM Benchmark Suite moves rigorous evaluation away from the cloud and directly to your local machine. Instead of requiring a massive local GPU, a unified API client acts as a central hub, routing prompts to external endpoints via OpenRouter and HuggingFace APIs. This fast system evaluates 10 mobile class models across 6 distinct tasks in about 30 seconds. It pulls standard questions directly from HuggingFace datasets, testing complex reasoning on HelloSwag and pure mathematics on GSM 8K. By outsourcing the heavy compute to APIs, benchmarking shifts from a multi-day hardware bottleneck into a fast, terminal-based software workflow. Grabbing the answers is only the first step. The engine does not just tally up the correct responses and print a raw score. The engine's core mathematical function is the Wilson 95% confidence interval. Every benchmark result passes through this filter to isolate the true signal. Pairwise z-tests and Cohen's H effect sizes then provide mathematical proof if a model actually outperformed its competitor, or if they tied. Enforcing this strict statistical rigor completely removes the risk of selecting a model based on a deceptive 1% variance in a flat score. When you run this test across the current landscape of 1 to 4 billion parameter models, the results clarify exactly where these lightweight AIs succeed and fail. Plotting model size against GSM 8K math accuracy reveals a sharp cliff. Performance plummets below the 1 billion parameter mark. Conversely, Microsoft's 5.4 Mini at 3.8 billion parameters achieves a proven 72% accuracy, mathematically separating itself from the pack. The suite takes pairwise comparisons, precise confidence intervals, and raw benchmark scores, generating a clean HTML and PDF report directly in your local output folder. You no longer have to guess which small language model fits your application. You can base your deployment entirely on verifiable local math.